Hey guys, Miss Riggs here. Welcome back. We are going to start a new unit this week, and our new unit this week is going to talk about evolution and evolutionary theories. Um, this unit is a little bit tricky, but I think it is really important for y'all to understand the theory of evolution and how, and to really research your own ideas about the differences and maybe the similarities between evolutionary ideas and creationist ideas. Um, in order to share your convictions, it's really important that you know both sides, especially if you're debating your beliefs with somebody else. Um, but I also think it's really important for us to understand two sides of an argument in general. The more education we have about ideas, the better we are. So this week we're going to really focus on kind of seeing both sides of those. We're going to compare and contrast evolution and creationism, and we're going to have really good discussions in class over these concepts. So this week we have some vocab words to share, and so make sure that you're filling out your vocab sheet as we go through these vocab words today. So our first vocab word, obvious choice, evolution. And this is the process of biological change by which descendants come to differ from their ancestors. So this doesn't necessarily always mean that we're changing species. It could mean that, but it's also referring to just the change within a species overall. And this actually happens on an everyday basis. If you know anything about bacteria, and I'm sure we'll discuss this more in class, but bacteria is changing and evolving all the time at a very quick rate. That's just a really primary example. Species. Species is a group of organisms so similar to one another that they can reproduce to have fertile offspring. So that's the most important part of the definition of species, is that they can produce offspring. So some different species might look very, very similar, but if they can't produce offspring as a species as a whole, then they are not considered a species. A good example of this is when we talk about a mule. So a mule is when a horse and a donkey mate and create a mule. There's lots of reasons why you'd want a mule. I'm not going to get into those. But this mule offspring cannot reproduce itself. So it is not considered an actual species. And nor is a donkey and a horse considered the same species, because they cannot continue to procreate or have offspring. A fossil. A fossil is a trace of organisms that existed in the past. So fossils can be formed in multiple ways, and we'll talk about those different ways as a class. Catastrophism. This states that natural disasters such as floods and volcanic eruptions have happened often during Earth's long history. These events shaped landforms and caused species to become extinct in the process. So we're going to talk about different theories associated with catastrophism, as well as gradualism and uniformitarianism, but we'll understand that concept a little bit more when we get into our lectures. So gradualism, this is a slow change over a long period of time. So gradualism, when we're talking about gradualism, we're talking about like erosion and rock formation, and just these processes that are occurring over a very, very long period of time. Uniformitarianism, this is the theory that states that geologic processes that shape Earth are uniform through time. So this means that whatever happened previously is going to be happening now. So it might be a very, very slow process, but nothing is changing. It's all happening the same way as it was happening when Earth formed. Variation, the difference in the physical traits of an individual from those of other individuals in the group to which it belongs. So I know we've talked about this before, but variation is really important for a species survival. This really helps a species adapt to new environments um, because without these variations, then the species would indefinitely die off if the environment changed at all. Adaptation. Adaptation is a feature that allows an organism to better survive in its environment. It can lead to genetic changes in a population over time. So, in adaptation, species are changing in order to survive in their environment. So, if their environment is changing, they're going to adapt to this change over multiple generations. So, that's not saying that a certain organism within a species is changing, because that's not true. Just the species that are have better adaptations, or the organisms in a species that have better adaptations to survive in that changing environment, are going to reproduce more, and so gradually that species will start to change. Artificial selection. So this happens quite often. This is the process by which humans change a species by breeding it for certain traits. We do this all the time. It happens in agriculture, in our pets. This happens when we are producing crops. If you can see up here, this is what a banana used to look like, or a natural form, and we have actually created the banana that we know and we eat through artificial selection. This is a kind of an ostentatious example of artificial selection, but we artificially select for cattle that produce maybe more meat and less fat in order to get a better product. And then our pets, we have artificially selected for certain pet species in order to fit our needs as pet owners. So heritability, this is the ability of a trait to be passed down from one generation to the next. I think that's pretty self-explanatory. We have a mom and a dad, and we have heritable traits that are passed down. Natural selection, a mechanism by which individuals that have inherited beneficial adaptations produce more offspring on average than do other individuals. So I was talking about this concept when we were talking about adaptation, but if there are a variety within a species, then certain organisms within that species are more likely to succumb to being eaten by prey, or not surviving certain temperatures. Those are just a few examples. But natural selection states that these organisms that are not well adapted to the environment are going to die off in some form or another. So in this case, the green beetles are going to eventually start to die off, and then there will be more of these orange beetles because they will be the ones reproducing because the prey are eating the green beetles. So that is an example of natural selection. Population, all the individuals of a species that live in an area. So it's important to distinguish between population and species. You can have the same species on different continents, but you cannot have the same population on different continents. They need to be able to reach each other. So you can have a species of deer here in North America, and you can have that same species of deer, say, in Africa. But they are not going to be the same population because they cannot come together and they cannot breed in that population. Fitness, a measure of the ability to survive and produce offspring relative to other members of the population in a given environment. So that goes with natural selection. If an organism has better fitness, it's going to be more likely to survive. So homologous structures, these are features that are similar in structure but appear in different organisms and have different functions. So different organisms have similar bone structures in certain structures. So this is a picture of a human arm and a cat arm. and a whale fin, and a bat. So we have similar bone structures within all of these organisms, and they do perform different functions. So that's a homologous structure. An analogous structure is a structure that performs a similar function but are not similar in origin. So they've adapted to their environments and from different branches or different origins, and they've established an adaptation that suits their environment. So we have here butterfly wings and we have bat wings. These are analogous structures because they perform a similar function, but they are not from a similar origin. Vestigial structures, these are remnants of organs or structures that had a function in an early ancestor. So there are certain animals or organisms that have these vestigial structures, and basically they don't function, they don't have a function for them now, but they did at one point in their evolutionary cycle. So we have a whale here, and we have a pelvic bone and a femur. This doesn't really do anything for the whale at this point, but the theory states that it once may have functioned as a hind leg bone before the whale had evolved. And then paleontology. This is the study of fossils or extinct organisms. Okay, so those are all of our vocab words for this week. So make sure you fill out your vocab words, fill out any sentences that you need to fill out, and I'll see y'all in class.